In section 1.1, problem number 69, homework, we get this word problem. In 1999, Parks Bonifay became the first wakeboarder to land a documented 1,080-degree spin in the air. So he started, let's say he started at this initial position, and he went 360 degrees, and then he kept going to 720, and then all the way to 1080. So he did 3 turns around, and he landed facing the same position he started in. And then in 2006, Danny Harf collected that amount for a reward for doing it again. And then in 2008, Harf went even bigger. He kept going this time, and he kept going all the way to 1260. So let's actually do that in a green. So he did those 3 spin, that 1,080 degrees, and he kept going till he got to 1260. Let's do that 1260 there, and let's note that this blue line is 1080. I'm drawing the visual here because it helps my brain process it, but it's not necessary to do this problem. So this question is asking us now, were these 2 spins coterminal? And you can tell from my diagram that it looks like they're not, right? It looks like they do not land, the blue one and the green one do not land at the same position. But again, what if you didn't draw the diagram? How to tell if they're coterminal is if they're exactly any multiple of 360 away from each other. So everything that's coterminal with 1080 is plus or minus some multiple of 360. So what we can do is take that difference, find out if they are 360 or some multiple of 360 apart. So I'm just going to subtract them and see if they end up being 360 degrees apart. Borrow 1, 8, 1, and I get 180. So there's a 180 degree difference. So when he went that bigger spin, he went 180 degrees extra, which is not coterminal because it's not a multiple of 360. So I can see through the calculation that no, this is not, these angles are not coterminal. And it matches with my visual of that. Okay, and the second question asks us to find the 2 smallest positive spins that are coterminal with that 1260. So starting with that 1260, I can just start subtracting 360s until I get to something very small. But I'm not to the negative one. I make sure I don't go negative. Okay, so let's get a calculator to do that one. So I can start at 1260. I'll go ahead and make that bigger. And if I subtract 360 once, you can see I get the 900. Not very small. I can still go smaller. Let's keep going. Then I get 540. I can still keep going and still stay positive. So if I subtract 3 360s, then I'm left with 180 degrees. And if I keep going after this, then it's going to go negative. So 180 is the smallest possible. So if I'm going to subtract 3 of these 180s, 360s, then I'm left with 180 degrees as the smallest possible. Coterminal angle, and then the next smallest would be 360, that plus 360, which would be 540, which would be the second smallest coterminal angle. All right, so there's my final answer. So I'll say smallest positive spin that is coterminal with 1260 degrees. And this is the second smallest positive spin that is coterminal with 1260. So, final answers. The first question, no, these angles are not coterminal. And the smallest and the second smallest coterminal angles are here and here.